Here we see the inline vacuum coating plant for plates and metallic stripes of FEP called MAXI. The multi-chamber system has a modular design and consists of 8 chambers. In the strip mode, coating is performed in a roll-to-roll process. In the plate mode, the substrates are transported by carriers which move individually through the system. The main coating processes used are high-rate electron beam deposition, in particular plasma-activated high-rate electron beam deposition, but also pulse-magnetron sputtering. Winding station, insertion of the substrate. Various processes can be installed to pretreat the substrates. For example, tempering the substrates using radiation heaters. Another example is cleaning the substrates using plasma etching. The animation shows magnetron etching. On the substrate bottom side, which is the coating side, an intense plasma ignites. Thus, the substrate underside is cleaned by ion bombardment. The plasma can alternatively be cleaned by hollow cathode etching. Magnetron sputtering enables the deposition of thin intermediate layers, which also serve as a diffusion barrier or adhesion-promoting layer for pretreatment. In the first coating station, coating is done by electron beam evaporation. The electron beam heats the evaporation material in a crucible until it vaporizes. The vapor then condenses on the substrate and forms a coating. Various variants of electron beam evaporation are possible. One example is the electron beam Co-Evaporation. Here, 2 crucibles with different evaporation materials are used. The electron beam jumps between the 2 crucibles. This is realized by rapid deflection through a variable magnetic field. The respective dwell times of the electron beam determine the evaporation rate. Coating Station 2 shows the example of plasma-activated electron beam evaporation. Here, a diffuse arc discharge serves as plasma source. The intense plasma is located in the immediate vicinity of the substrate. Vapor particles pass through the plasma cloud on their way to the substrate. This increases the energy of the vapor particles and enables the deposition of particularly dense and smooth layers. Post-treatment. The layer thickness can be measured using X-ray fluorescence. The device for this is located in the post-treatment chamber. Here, the thickness of the deposited layer can be checked and adjusted if necessary. Tempering the substrates after coating, for instance, reduces internal stresses or accelerates diffusion processes within the layer or between substrate and layer. Unwinding.